Hello students, I am Mr. Praveen Kude. Today we are going to see the 11th physics second chapter mathematical methods. In previous chapter we have studied different aspects of physical quantities like physical quantities. Different aspects, that is the first is fundamental quantity. Fundamental quantities and derived quantities. What is physical quantity? Quantity which can be measured is a physical quantity. These two aspects are studied in previous, that is the fundamental quantities and derived quantities, along with their units and dimensions. Along with their units and dimensions. This is studied in first chapter. Now, when we think about the physical quantities, all physical quantities may not be fully described by their units and magnitude alone. All the physical quantities cannot be fully described by magnitude and units alone. For that, we have to see one example. We are given time for which the person walk with certain speed. By knowing these two quantities, that is you are given time for which the person walked with certain speed, you can easily find out the distance covered by the person. But we cannot find out where the person exactly reached unless we know the direction. In which that person walked. Direction is most important to give the final destination of the person. So this is one more term added in this chapter. Now, according to this example, distance traveled by the man is given by magnitude and unit. Hence, this distance is scalar quantity. This distance is called as scalar quantity. It does not need the direction. There are some physical quantities which are described only by its magnitude. It does not need the units. Now again think about the example. Final position of the person with respect to initial position. Final position of the person with respect to initial position of the person. That is the displacement. Displacement can be described by displacement can be described by magnitude and direction. Hence, here direction is needed. Hence, this displacement is the vector quantity. So, today we are going to see what are the scalars, what are the vectors. Now, one more word is there which we want to find out the final position of the person. What is the position? That is, position in space is the point at which given object or the particle exists at a given instant of time. That is the position. When we want to find out such a position, we need the direction and magnitude, because that position can be found out with respect to the origin of the coordinate system. Now we are going toward the definitions of scalar and vectors. Scalars. What are scalars? As this distance is scalar quantity. Physical quantity which cannot be completely described. Physical quantities which can be completely described by their magnitude alone. Is called as the स्केलर क्वांटिटी. जी क्वांटिटी डिस्क्राईब करण्यासाठी फक्त आपल्याला मॅग्निट्यूडची गरज असते त्याला काय म्हणायचं? स्केलर क्वांटिटी. आता याचे एक्झाम्पल सांगायचं असेल तर देर आर डिफरंट एक्झाम्पल. दॅट इज डिस्टन्स. दिस इज डिस्टन्स. व्हॉट वी कन्सिडर इन द एक्झाम्पल? डिस्टन्स, स्पीड, मास, टाइम, टेम्परेचर, density, work, power, frequency, electric charge, electric current, electric potential, resistance, capacity, magnetic pole strength. These are the more examples of the these are examples of the scalars. I told you this number of examples because they are useful in MCQ. So these are the examples of the scalars. One more thing about the scalars, they are specified. These scalars are specified by number and unit. Now by taking example how they are specified, for that we have to take one example. That is if you are given a rod, metal rod, which having length 2 meters, it means the rod is two times the certain standard unit. Meter. It is 2 times the standard unit, the meter. That is the 2 meters is the length of the metal rod. This shows that this length is described by the number and unit. Meter is the unit of the length. This number and unit together gives the complete idea about the length. Hence it is a scalar quantity. Similarly we can see the other examples as I told you. Now we are going to the definition of the vector. Physical quantities which need magnitude as well as direction for their complete description. Such a quantities are called as vector quantities. Physical quantities which need magnitude as well as direction for their complete description are called as vectors. Now we think about example of the vectors. In previous example we say that the displacement is the vector quantity because it needs magnitude and direction for its complete idea. Okay, displacement is example, then velocity, displacement, velocity, acceleration, linear momentum, force, impulse, torque, magnetic moment, magnetic induction, field, intensity of electric field. These are the examples of the vector quantity. These are examples of the vector quantity. Now consider the displacement. If you consider a body is displaced from point P to Q, initial position is P, final position is Q, and then the vector is represented by this P Q. This displacement vector from P to Q can be represented by in this way, where P, what is this P? P is the starting point of the vector. It is called as tail. त्याला काय म्हणायचं? Tail. Though it is starting point, it is called as tail. And end point Q, this end point Q, which has an arrowhead, it has an arrowhead, is called as the head of the vector. Head of the vector. And symbolically this vector is represented by PQ bar. This is a symbol of representation of the vectors. This is all about the vector quantity and what is the vector, definition and its examples and how they are represented. Now we are going to see the different types of vector. Different type of vector. First example, zero vector. First type is the zero vector. It is also called as null vector. Zero vector or null vector. What is its definition? This zero gives you idea about the definition. That is a vector having zero magnitude. Zero magnitude. Vector with zero magnitude is called as the zero vector. But this is incomplete definition. Vector having zero magnitude with particular direction. With particular direction. Because as this is a vector, it needs direction. So vector with zero magnitude in particular direction is called as a zero vector or null vector. And symbolically it is represented by zero vector in this way. Now, though they are not given in this book, and there are few properties can be explained in previous book. For knowledge, we have to see the properties. First one, if any vector can be added to zero vector, then it gives the non-zero vector. If this non-zero vector is added to the zero vector, that is given the original non-zero vector. Okay, second one, if any scalar, lambda is any scalar, we have to consider this scalar. If any scalar is multiplied to zero vector, that is also give zero vector. Okay, another property, If non-zero vector is subtracted from itself, it also gives a zero vector. These are the few properties of the zero vector. They are not in book. Okay. For MCQ, where it is needed, think. Now, what are the examples of the zero vector? Velocity vector of a stationary particle is zero vector. Velocity vector of stationary particle. Velocity vector and stationary particle. Distance upon time is the velocity. If the particle is stationary, that means there is no displacement from the initial position. That is, the distance travel is 0. 0 divided by given time is the zero vector. Okay. Another example. Acceleration vector of object. Acceleration vector of object moving with uniform velocity. Acceleration vector of object moving with uniform velocity. Acceleration and uniform velocity. Uniform velocity, there is no change in velocity, and acceleration is the rate of change of velocity with respect to time. So this gives you zero vector. These are the examples of the zero vector. Now we are going to the next definition, that is the second definition, resultant vector. Resultant vector. The resultant vector of two or more vectors, because we have to find out a resultant of two or more vectors. So resultant of two or more vectors is a single vector. It is the resultant vector is a single vector, but it is a resultant of two or more vectors. So definition is given by resultant of two or more vectors is that single vector which produces the same effect. This produces same effect as produced by all the vectors. Same effect produced by all vectors together. All vectors. This is the single vector. So definition of the resultant vector is, again I repeat this, the resultant of two or more vectors is the single vector. Is that single vector which produces same effect as produced by all the vectors. This is the resultant vector. Now we are going to the next definition, that is the negative vector. Negative vector. It is also called as opposite vector. Opposite vector. What is the definition? Negative vector of a given vector. Negative vector of a given vector is a vector of same magnitude but opposite direction. Negative vector of a given vector. Negative vector of a given vector is a vector of same magnitude but opposite direction to the given vector. Opposite direction to that of the given vector is called as the negative vector. As this direction is opposite, it is called as opposite vector. So, negative vector. Now, suppose vector A bar. This is vector A bar. And this is vector B bar. This B bar, vector B bar, is negative vector of vector A bar. B bar is the negative vector of A bar because it has, though it has the same magnitude, but it has a opposite direction of the A bar. Hence, it is the opposite vector or the negative vector of vector A bar. Now, we are going to the next definition, fourth definition, that is the equal vectors. Equal vectors. Suppose vector A bar and B bar, these are the two vectors representing same physical quantity. Representing same physical quantity. Same physical quantity. Are said to be equal. Are said to be equal if and only if they have, if and only if they have same magnitude. Same magnitude, distance, same magnitude and same direction. Same magnitude and same direction. Then and then such a vectors are called as equal vectors. Again I will repeat this. If A bar and B bar are two vectors of representing same physical quantity, are said to be equal if and only if they have same magnitude and same direction. Graphically, now we have to consider this vector A bar and this is vector B bar. This has same magnitude as well as same direction. Hence these two vectors are the equal vectors. These are the equal vectors. Now the last definition is unit vectors. It is most important part. Unit vector. Unit vector. This unit word also give the definition. A vector having unit magnitude. Vector having unit magnitude. Vector having unit magnitude is called as unit vector. But though it has a unit magnitude, but the direction, though as it is vector, so we have to again think about the direction. So a vector having unit magnitude in a given direction, given direction is called as unit vector. Vector having unit magnitude in a given direction is called as the unit vector of the given vector. Okay. Now we have to consider if M bar is any non-zero vector. This is non-zero vector. Non-zero vector. Non-zero vector. And unit vector, its magnitude is given by its magnitude. is m is equal to magnitude of m bar. This is magnitude of m bar. It is not 0. It is not equal to 0. Now, unit vector along m bar. Unit vector along m bar. Unit vector along m bar is um cap. This is unit vector along m bar, and it is given by this m bar is equal to um cap into m. This gives you direction and this is magnitude. Combining these two gives you exact idea about the given vector. This unit vector always gives the direction of the given vector. So again we can write solid for the unit vector. This is the m bar upon m. This means unit vector is equal to vector divided by its magnitude. Okay, vector divided by its magnitude, and it has always direction of the given vector. When easy think, this is the explanation about a single vector. If we think about rectangular coordinate system, three-dimensional rectangular coordinate system, we use for three-dimensional rectangular coordinate system we use I, j and k as a vector along x, y and z direction. Along x, y, z direction. Then this ux cap is the unit vector along x direction. It is given by I cap. Uy cap, it is the unit vector along y direction and it is given by j cap. Z cap, it is the unit vector along z direction and it is given by k cap. Now these vectors are given by I cap is given by x bar upon x, j cap is given by y bar upon y, and k cap is given by z bar upon z, vector divided by its magnitude. This x bar, y bar and z bar are the vectors along x, y and z direction. Okay, this is all about for unit vector. This finishes the definition of the unit vector. This is important for examples also. This equation is used in short examples also and MCQ also. Thank you.